Hi, I'm Alex Pault with Open Systems Media and Embedded Computing Design, and I'm here at the Things Conference with Benjamin Guilloud. He's with ST Micro, and well, I've known that company for years, everybody knows the company, but I understand you have something like new and like really different, not just a new thing or a different color or whatever, you have something actually new to report here at the event.
Exactly, Alex. Hi. So indeed, we are the first, actually, we are glad to be the first in the world to bring what we call a system on chip on the market. So basically that means that both the architecture of an STM32L4 microcontroller and a LoRa-enabled IP are embedded on the same silicon die. Up to now, all the implementation on the market have been done in a discrete way, which meant either there was one package for the MCU and another package for the LoRa transceiver on the same PCB, or one package for the MCU and another package for the LoRa transceiver in the same module, or even sometimes one silicon die for the MCU and another silicon die for the LoRa transceiver inside the same package, which is in that situation is called a system in package. Here, with the STM32WL, it's a totally new approach. Everything is embedded on the same silicon die, so much more integration.
So now, recognizing that we're talking SoC and there's never a completely pure SoC, what exact peripheral components are needed on the outside? Just some minor passives?
So, yeah, exactly. Actually, what you will need to do from a hardware standpoint on your PCB will be the impedance matching. And yeah, you will need to select the frequency at which you want to communicate. And basically, that's it.
Everything else is on chip?
Yeah, of course. You will also need to select what we call 32 megahertz crystal. Okay. Up to recently, you actually needed 2 crystals because the implementation were discrete, as I just explained. And so you save 1 crystal, and you have less external components actually around the SoC. Yes.
Well, that must also mean lower power consumption, more efficiency?
Of course. Yeah, the key points that I could highlight, first of all, are indeed ultra low power, because it's based on the STM32L4 microcontroller, which is a best-in-class MCU. And the other key points that I could focus on right now with you are the following ones. First of all, there is multi-modulation capability. That means that device makers will be able to implement other protocols than LoRaWAN, okay? Such as other proprietary protocols or other standardized protocols, for example. Also, I've already mentioned the deep integration coming from the SoC aspect. But another point to highlight could be the fact that we provide this device in a fully open way. That means that device makers are absolutely free to implement whatever they want into it, which is a very open product.
Which is interesting. Normally you think of a modular solution as being dial-inable, scalable, or convertible in certain ways, but you're basically got this SoC, but you're leaving it open for...
Exactly. We are making the device maker's job much easier, actually.
Well, you know what? Yes, much easier, but because I think that the burden has shifted to integration and understanding how the subsystems work together, you're giving them more tools and you're giving them a better solution, but if they don't understand how it all works together, they're still going to need some help.
Yeah. Yeah, sure. Yeah.
Now, speaking of that help, what kind of engineering support are you offering on this device? Development kits, reference designs?
So yeah, we are bringing what we call an introductory ecosystem with such device. That means what we call Nucleo boards for flexible prototyping, but also software tools, such as what our tool called Cube Programmer. We have also CubeMX for, or light version of CubeMX for pinout configuration or clock tree synthesis. We have IDE compatibility with ARM Kyle or IAR systems, for example. And last point would be, what would be the third point? Yes, the LoRaWAN stack itself. Actually, the LoRaWAN stack is provided in a source code format. And actually, this stack is production ready and certified for all the LoRaWAN regions in the world. So wherever you are, whatever market you target, you are able to use our LoRaWAN stack for your productions.
Very cool. Now, Benjamin, is there anything else about the device that you'd like to leave with our audience that they would need to appreciate?
So yeah, of course. I've already highlighted the multi-modulation capability, the deep integration coming from the SoC approach, the openness of such products, I highlighted also maybe the fourth point I've already.
What about security?
Yeah, I was about to mention this one actually. So we have safety features and security features as well. We could think of AES for encryption, AES 256 bits. We could think of firmware protection capability with what is called PCROP, so program code readout protection, or public key accelerations as well, or anti-tamper detection. You really want to protect your device from any kind of attacks, such as physical ones, for example. So if devices have been tweaked or opened, we are able to detect that. And yeah, that's another point to highlight. The offering right now is coming with a BGA73 package, so tiny footprint. Up to 43 GPIOs can be enabled, which provides nice flexibility for our customers. Okay, and we have a 10 years lifetime commitment, meaning that we are actually committed in ensuring that our customers will be able to order the same part number for at least the next 10 years. And such commitment is renewed every year. So, so usually it lasts much more than 10 years.
Well, you're expecting a long tail, I'm imagining.
Yeah, of course. Yes, of course.
So, hey, Benjamin, thank you so much for taking the time to talk to us. Is there anything else you wanted to, a last word?
I think, yeah, I've covered the main key
Excellent.
points, yes.
Then thank you for taking the time. I really appreciate it.
Thank you so much, Alex.